Difference quotient. What is it? And why do we care? Well, first of all, you might have seen the difference quotient as x of x plus h plus f of x divided by h. Great. What is it and why do we need it? All right, let's break it down. So let's say we have ourselves coordinate plane and we have 2 points. Through those 2 points, we have a curve. Whatever, great. Generally, okay, now, through those 2 points, we can also say, well, if we have a line through those 2 points, we would have a slope of that line. And you might remember slope is y2 minus y1 over x2 minus x1. Just thinking back on your algebra days. Great, keep that in mind. Now, back to our 2 points. I don't have any numbers on my coordinate plane, so I don't know the exact values of these. But I know that this is, we'll call this x1, and then the output of that would be the function of x1. Great, so x and y, basically. The other one would be x2 and the function, right, the output of x2. So I have myself 2 ordered pairs. If we think about the distance between these 2 points, right, we would say, well, that would be f of x sub 2 minus f of x sub 1, because that's the change in the y values. Similarly, if I go this way, the change in the x values is x2 minus x1. Well, okay, great. To make things maybe a little easier, let's say that x2 minus x1 is h. Let's just give that a value of h. This also means that x1 is the same as, back that up, x2. x2 is the same as h plus x sub 1, right, if I isolate this variable. The reason I'm doing that right now is because right now there's a lot of x's in here. So if I redo my ordered pairs, and I could say, let's make this ordered pair just x f of x, and then with x sub 2 being the same as h plus x1, this would be x plus h with the output of f of x plus h. Now, using these ordered pairs, think about slope. Okay, why? So if I take y1 minus y2 over x minus x2 minus x1. Well, you'll notice here that these x's will cancel out, and I am left with f of x plus h minus f of x all over h, which is the definition of slope, right? So the quotient, the difference quotient, is simply the change over time. It's slope. It's everything we've done in algebra, but now it's written in a slightly different way because the difference quotient is used to define a derivative. So we get into calculus with the difference quotient. So the reason you do this so much in algebra is because algebra is kind of the gateway to calculus, and you have to understand this maybe more involved way of finding slope, because not everything is a straight line. And so we have to make sure we know how to find the change over time between 2 points, even if it's not a straight line. Now, one other thing about the difference quotient is that the difference quotient is more meaningful when h is small. What that means is, if you think about what h is the difference between the two, the x values of the 2 points. And if we're talking about 2 points, let's just say we have a point here, a point here and a point here. Well, there could be a very big difference between those 2 points, right? It's going to be harder to estimate if we're thinking about a line through those 2 points. Whereas if we had an ordered pair and we had points here and here, right, where h is very small, even if we have a big curve, because the points are closer together, h is smaller, we're going to have a more accurate slope. So the smaller h, the value of h, or the difference between the x values, that's going to be a more meaningful difference quotient, a more meaningful slope. Okay, the change over time is going to be more accurate or more precise when we have a smaller h value. It's not going to be exact, but it's going to be better than what we had before. Okay, so that's just a little bit of what the difference quotient is and why it works.